Hi, I'm going to be talking about nomenclatures of alkane organic chemistry. I have a hand-drawn table here that shows the number of carbons, the molecular formula, the name, the condensed structure, and the skeletal structure. So the name of these alkanes are very important for you to know for your organic chemistry 1 and for those of you who are going to be doing organic chemistry 2. So the condensed structure shows you like the long chain, and the skeletal structure doesn't show like the hydrogens. And the reason why methane doesn't have a skeletal structure is because the skeletal structure shows you a carbon-carbon bond and not a carbon-hydrogen bond. So if you see methane is just carbon bonded to 4 hydrogen, so it doesn't have a skeletal structure per se, but the name is very important, and then the name shows you how many carbon is bonded to another carbon. So for instance, a 4 carbon chain is going to be butane, a 7 carbon chain is going to be heptane, a 9 carbon chain is going to be nonane. So I have written out the rules guiding the naming of alkanes. Also, I have a pre-drawn questions to show you like how it's related to the rules. So the first rule says to determine the parent hydrocarbon chain, which is the longest carbon chain and would always be the last name of the alkane. So this first example here is just a straight chain and has how many carbons? It has 1, 2, 3, 4, 5, 6, 7. Has 7 carbons, so it's going to be heptane because the 7 carbon chain is heptane. So the second example here is we're going to have to determine the longest carbon chain since we have a substituent branching off, which is which I'm going to discuss about later. But first, we need to determine the longest chain is 1, 2, 3, 4, 5, 6, 7. And let's see if the substituent is a longer chain than the straight chain. So we'll go 1, 2, 3, 4, 5, 6, 7. So we know our pHc is 7. So I'm going to erase the naming, the numbers I wrote out here, and I'm going to explain why I did that later. But here we have to have the substituent carry the lower number. So we have an ethyl, a 2 carbon chain, which is ethane, branching off of carbon number 3, but because it's a substituent, we name it ethyl. We're replacing the ane with the yl, and since it's branching off of number 3, carbon number 3 is going to be 3-ethyl heptane. The second rule says the name of the substituent, which is the carbon that branches off the pHc, is always placed before the pHc name. The chain is numbered in the direction that gives the substituent the lowest possible number. So from the first example, we have to first of all determine the pHc, which is the longest carbon chain. So I'm going to be counting from left to right. So you have 1, 2, 3, 4, 5, 6, 7. And since we have a substituent branching off, we have to determine if the substituent would make the chain longer than 7. So we have 1, 2, 3, 4, 5, 6, 7, 8. So since 8 is greater than 7, our pHc is going to be 8. So the rule also says the chain is numbered in the direction that gives the substituents the lowest number possible. So I'm going to go ahead and number the chain in the other direction. 1, 2, 3, 4, 5, 6, 7. Oh, sorry, I missed a carbon there. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So this is our substituent, and we're picking between 5 and 4. But since 4 is less than 5, 4 is going to be the number that branches the number 4 is going to be the number where the chain branches off. So we're going to have 4-ethyl because it's a 2 carbon chain, octane, and octane is the pHc. So for the next example, we're going to do the same thing. The first thing we do is determine the parent hydrocarbon, which is 1, 2, 3, 4, 5, 6. It's obvious that the straight chain is the longest chain. But to determine the direction that gives the substituent the lowest possible number, we also would have to number it in the direction, in the opposite direction, 5, 6. So we have a branching off of carbon number 3 and 4. And in the opposite direction, we have it on also number 3 and 4. And since we have it the same way, we could go with either direction. So we're gonna have a 3,4 dimethyl. I say di using the prefix because we have a methyl chain, which is methane, but because it's a substituent, we're using the YL. We have 2 methyl branching off of carbon number 3 and carbon number 4, and our pHC is 6, which is going to be hexane. And that's it. So our next rule says if there is more than one substituent, the substituent is numbered in the direction that produces the lowest number possible. And they're listed in alphabetical order. Also, if there are 2 or more identical prefixes such as di, tri, or tetra are used to indicate the number of substituents. Okay, so first thing first, we have to determine the parent hydrocarbon. So we have 1, 2, 3, 4, 5, 6, 7, 8. And since this other chain looks like it's long, we're going to try to 1, 2, 3, 4, 5, 6, 7, 8. Okay, so since both ways give us 8, our parent hydrocarbon is 8 carbon chain. So now secondly, we have to determine which direction gives us the lowest possible number. So when going from left to right, we have our branching off of carbon number 3 and 5. And going from right to left, we have our branching off of carbon number 4 and 6. So 3 and 5 is lower than 4 and 6, so I'm going to go ahead and erase this. On carbon number 3, we have a ethyl. And on carbon number 5, we have a methyl. So now the rule says after getting the lowest possible numbers, then we name them alphabetically. So since E comes before M in the alphabet, it's going to be 3 ethyl, 5 methyl, and then the parent hydrocarbon octane. So for the next example, we're going to do the same thing. Determine the parent hydrocarbon 1, 2, 3, 4, 5, 6, 7. And if we go the other way, we go 1, 2, 3, 4, 5, 6, 7. So our pHC is 7. So now I'm going to number it in the opposite direction. 1, 2, 3, 4, 5, 6, 7. So we see that both substituents are branching off of carbon 3 or 5. And since 3 is less than 5, we delete the 5. So on carbon number 3, we have a ethyl and a 3 methyl. So we can now use di-tri because ethyl and methyl are different. And we have to name them alphabetically in alphabetical order. So that's 3 ethyl, 3 methyl, and then the parent hydrocarbon heptane. So the third example, we see that the long chain is the pHC 1, 2, 3, 4, 5, 6, 7. So our pHC here is 7. And then when we number it in the opposite direction, 1, 2, 3, 4, 5, 6, 7. So going from left to right, we have 3, 5, and then going from right to left, we have 3, 5. So it doesn't matter which direction we go, we get the same number of substituents branching off of the carbon. Since we have the same substituent, we have a methyl, then we use a dimethyl. 3, 5 dimethyl heptane. So our next rule here says if either direction leads to the same lowest similar for one of the substituent, number the chain in the direction that gives the lowest number possible. So first we determine the pHC 1, 2, 3, 4, 5, 6. Either ways it goes all the way to 6, and our pHC 6. So now I number it in the opposite direction. 1, 2, 3, 4, 5, 6. So we have our branching from left to right, we have a 2, 5, 5. And then going from right to left, we have a 2, 2, 5. Because on carbon number 2 we have 2, and on carbon number 5 we have 1, substitute 1. So because 2 is less than 5, we're going to name it in the direction from right to left, and that would be 2 to 5. 2 to 5. And since we have the same substituent, which is methyl, we say trimethyl. Trimethyl. Trimethyl hexane, which is our parent hydrocarbon. For our next example, we're going to determine the parent hydrocarbon. 1, 2, 3, 4, 5, 6, or say 1, 2, 3, 4, 5, 6. Okay, so our pHC is 6. So I'm going to erase this and put it right here. 5, 6. So now we're going to determine the substituents branching off. We have a 3, 3, 4 going from left to right, and we have a 3, 4, 4 going from right to left. And since 3 is less than 4, we're going to go from left to right, number and name. So from carbon number 3 we have a ethyl, so 3 ethyl. We have a 3 methyl, and we have a 4 methyl. So we're gonna name it alphabetically. So 3 ethyl, because E comes first in the alphabet, and then 3, 4 dimethyl hexane. Our next rule says when the same number are obtained when numbered in the same direction, the lowest number is named first. So we're going to determine our parent hydrocarbon. 1, 2, 3, 4, 5, 6, 7. And we're going to go the opposite direction. 1, 2, 3, 4, 5, 6, 7. We have a pHC 7. So I'm going to erase this and just write it here, 6, 7, to avoid confusion. So we have our parent carbon branching off of carbon number 3 and carbon number 5, going from left to right, and then from right to left we have a 3 and 5. Okay, so we have an ethyl branching off of number 3, going from left to right, and 5 methyl branching off of carbon number 5, and we're going from left to right because ethyl gives us the lowest number possible and is named first. Both ethyl and methyl gives us a 3, 3, but because E comes before M in the alphabet, then we go with E and give 3 to E because E comes before M in the alphabet. And our parent hydrocarbon is heptane. So our next rule says when there is another substituent branching off a substituent, then you use parentheses. When naming, priority goes in alphabetical order. So for this example, we're going to determine the parent hydrocarbon. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then go in the opposite direction. We go 1, 2, 3, 4, 5, 6, 7, 8, 9. So our substituent is branching off of carbon number 5, and our pHC is 9. So on carbon number 5, I'm going to use a different color. We have a 1, 2, 3, which is a propane branching off of carbon number 5. And on carbon number 1, we have a methyl. So we're going to name it as 1 methyl propyl, and nonane. That will be our PHC. So basically it's just like we have a 3-carbon chain, which is our propyl, and a methyl branching off of carbon number 1. And all of this substituent is branching off of the main carbon number 5 chain. So that's why we have it in parentheses. So for our next example, we're going to determine the parent hydrocarbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to number it in the opposite direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our PHC is 10. Since numbering in the opposite direction, we have a number less than 10. So 10 has the highest number. So I'm just going to go ahead and erase this and number it 6, 7, 8, 9, 10. So we have a 5 and we have a 6. So since 5 is less than 6, we're going to go with the direction from left to right. So from carbon number 5, we have a 3-carbon chain. 1, 2, 3. And on the 3-carbon chain, we have 2 methyl branching off. So from carbon number 5, we have a propyl. PHC of the substituent is 3, so propyl. And we have a 1,2 dimethyl. Propyl. I'm going to erase this. And the PHC is 10. So PHC is 10. And we have a propyl, and the PHC is decane. So basically the substituent is telling us of branching off of carbon number 5, we have a 3-carbon chain, and branching off of the 3-carbon chain, we have a 2-methyl on carbon number 1 and carbon number 2.